An introduction to the control of flux. Metabolic control analysis was developed in the 1970s by Kachar and Burns and Heinrich and Rappaport. It quantifies the distribution of control in biochemical networks. We'll use a small example pathway, a linear sequence of 3 reversible enzymatic reactions, and we will experiment changing the amount of enzyme 3, or its Vmax. We will allow the Vmax to increase or decrease. So let's get started by first measuring the pathway flux at one value of Vmax. Now we increase the Vmax and measure the flux again. Notice that for a large increase in Vmax, we have a small increase in flux. If we further increase the Vmax, we measure the flux, and now the increase is even smaller. We now reduce the Vmax from its reference value and measure the flux again. And now the change of flux is proportionally larger to the change of Vmax. The slope of the tangent at each Vmax value tells us the effect of that reaction has on the overall flux. And a smaller slope means a smaller effect, a larger slope means a larger effect. If we now carry out the analysis on a double logarithmic plot, we arrive at the definition of a flux control coefficient, which is equivalent to the slope of this dependency of the logarithm of flux with the logarithm of the Vmax. And this was an introduction to the control of flux.